Welcome to this video tutorial where we're going to look at how to encode and decode Morse code using Python and using a binary tree. As you know, in Morse code, every letter of the alphabet is replaced with a sequence of dots and dashes. The way each letter was allocated a different sequence is not done randomly. In fact, it was done using a binary tree and a frequency analysis. So let's have a look at this binary tree. You can see here that the most frequent letter used in the English language are E and T, and they appear in the first level of our binary tree. And then you've got other frequent letters like I, A, N, and so on. And at the bottom of the tree, you've got less frequent letters. The way this binary tree works is if you want to find out the Morse code of any letter in this tree, you start from the root node and then you've got to locate that letter by following a path. Every time you turn left, you're going to assign a dot to your symbol. And every time you turn right, you're going to assign a dash. So for instance, letter A would become dot dash. Letter E is a single dot, and it's a very quick symbol to use when using Morse code. And that works quite well because E is a very frequent letter. And then a less frequent letter like letter X would be dash, dot, dot, dash. So let's go back to our Python challenge. Now I'm going to scroll down here and I'm going to go straight into the trinket, which I'm going to zoom in. Okay, so the first thing is we're going to look at how to implement the binary tree in Python. And to do so, we're going to use a class called node. And this class will have a single constructor here, which will initialize three values: the value of the node, and then whether this node has a left node or a right node. Okay, and per default, these left and right pointers will be set to none. So a node would be like a leaf without any left child or right child. Okay, and basically a tree is a root node. So you can see here on line 27, I'm creating my first node and I call it tree because that's going to be the root node of my binary tree. And the value, I'm setting it to start, but then I'm not providing any left child or right child at this stage. So this is a tree, but this is also a leaf. It's got no child nodes. Okay. Then I'm starting to add extra nodes to my tree. So on the left of the root node, if you remember, we had letter E. So I'm creating a new node here with the letter E as the value. And on the right of my root node was letter T. And then I'm going to build a second level. So I'm saying from the start, if we go left, this is now node E, and I'm going to look at what's at the left of node E. And if you remember, it was letter I. And to the right of node E was letter A. And so on. I'm going to do the same here with the right node after the root, which was letter T. And to the left of letter T, I'm adding N and then M. Let's have a look at the binary tree just to recap on that. So you can see here the root node start. To the left, we've got letter E. To the right, we've got letter T. To the left of letter E, we've got letter I. To the left of letter E, A, and so on. And then I'm going to be able to build the next few levels step by step. So let's go back to the code. You can see here the second level is now done, and then we're building the third level and then the fourth level. For the purpose of this challenge here, we didn't do the fifth level that contains all the number digits and a few punctuation signs. So we've kept it to just the letters of the alphabet. I've got a procedure here to draw the tree, and that will visually draw the tree on the screen. We don't need to look at how this procedure works, but it's been imported, and you can, if you really want to find out how it works, you can look at this tab here where the code is. And then this code here enable us to encode a message that is written in plain English into Morse code. So it's going to ask the user to input a code, it's going to convert it to uppercase, and then we've got a small for loops here to convert each character one at a time of the message. Okay, let's run this code to see what happens. So it's drawing the tree here just for us to be able to relate to it. And then we've got our input here. So we can type SOS, for instance. And this is now the Morse code for SOS. So you can see here, left, left, left is letter S. So that's dot, dot, dot. And then if we want to reach letter O here, it's right, right, right. That brings us to letter O. And then we've got letter S again. Now, same again, if you want to investigate how this code works here, we are looping through each character of the message one at a time. And for each character, we are calling a function here called getMorseCode. That is going to start from the root node, that's going to provide the character we're looking for, and that's going to build a string of dots and dashes, the symbol for the character. Now, the aim of this procedure here is going to locate the letter in that tree, and to do so we're going to do what we called pre-order traversal of the tree. So we're going to start from the root node, and then if the letter is not matching, then we're going to go left. If the letter is not matching, we will go left, and so on. And then we backtrack, and if we can't find the letter, we backtrack, and then we look on the right nodes, left, left, backtrack, and so on. Okay, that's a pre-order traversal of a tree, and you can see the code for this method here at the top. So get Morse code, that takes a node, the character we're looking for, and as we are scanning through that tree or traversing the tree, we're going to build a string of dots and dashes. Now, the way the pre-order traversal works is through a recursive function. Each time we call a functions to look for a node, we will have to repeat the process with the left node and repeat the process again with the right node. And that's done through a recursion. You can see here the recursion, the recursive call, so the function calling itself to search for the left node. And you can see here the recursion to search for the right node. Okay. Now this function is done for us and it works fine, and that's not quite the aim of the challenge here because that code is already done. The aim of the challenge now is to do the opposite, which means we want to input a Morse code string and we want to convert this back into plain English. Okay, so let's look at how we're going to do this. I'm going to keep this code here, so that will enable me to test different messages. It will give me a Morse code, and then I'll be able to copy this Morse code and convert it back to see if I've got the same as my original input. Okay. Okay, so we're going to add some code here at the end over there. Just for us to see it a bit better, I'm going to bring that up. And I'm going to start here. So the first thing I'm going to do is collect the Morse code from the user using an input. So Morse code equal input, enter a message in Morse code. Okay. And then we're going to use a similar approach where we're going to loop through each character to try to decode this Morse code. Now, the trouble is here, a character may consist of maybe one, maybe two, maybe three, and up to four characters, okay, dots and dashes. So in order to distinguish when a character starts, I'm going to look for the space between characters. So I'm going to split the string that the user will input using the space as the divider, and then I will be able to retrieve each symbol one at a time. Okay, so let's split our data. So I'm going to call it symbols. So that's going to be a list of symbols which will consist of splitting the Morse code that has been given by the user using the space character. Now, just to see if that works, I'm going to print symbols, just to see that I really have a list now of characters. So I'm going to run this. I'm going to press SOS, and then I'm going to copy this here, type it here, and effectively you can see here my list of symbols. Okay, we can ignore the last one here, but we've got them here. Perfect. So now that I've got my list of symbols, I'm going to be able to loop through each symbol one at a time using a for loop. So for each symbol in my list of symbols, careful here with the S. So I want each symbol in that long list of symbols. Okay. And this is where I'm now going to be able to access each character in that symbol and use it to decide from my root node whether I want to go left or whether I want to go right in order to locate the letter matching the symbol. So I'm going to say if, no, sorry, I first need to loop through each dots and dashes from that. So for each character in the symbol, so the character here will be a dot or a dash. We're going to say if the character is equal to a dot, in that case, we're going to navigate our tree going to the left. So what we need to is know which node we're currently at. Obviously, we will start with the root node. So I'm going to use a node that I'm going to call current node, that I'm going to initialize as being the root node, which we called tree. And then if my character is a dot, then I'm going to replace my current node with the left node. So I'm going to replace my current node with the left node of my current node. Otherwise, if the character is a dash, I'm going to navigate through to the right. So I'm going to say current node equal current node dot right. Okay, perfect. And then once I'm done, then I will have the current node. I will be able to retrieve the value of the current node. So the letter that I'm looking for, once I've finished looping through each character or each dot and dash in the symbol, I can now retrieve the value of my current node. So the letter would be the current node dot value. Okay, and what we could do here is concatenate this to a message. So let's have a message that is starting being initialized as an empty string, and what we're going to do is add this letter to our message. Okay, and once I'm done and I've gone through all the symbols in that list, then I can print the message, and hopefully that should return back to the message that we initially typed. So let's try that. So let's try with SOS to start with. I'm now going to input the Morse code. So I'm going to copy that into here, and hopefully it's going to return to the Morse code. Now it's not happy, so I must have done something slightly wrong here. Yes, what's probably happening here is that this probably works for the first character here. And when we move on to the next symbol, we need to reset our current node to the root node to start searching again from the top. So what I need to do is move this line of code here. I'm going to cut it from here, and I'm going to reset it at the start of each symbol. Okay, so that every time we start from the root node and we start navigating to up to the letter. Let's try that. So I'm going to copy that again, Perfect. So we've got our list of symbols, and then it's converted it back to the message. And I'm going to try that with a more complex message. I'm going to type hello world. Now remember, it doesn't matter whether I use lowercase or uppercase because it's converting it to uppercase anyway. This is the message, far more complex. I'm going to type that here and see what happens. Hello start world. This is probably because of the space we've got here. So we may want to add an if statement here to say that if one of the values in the list of symbols, is empty, then we shouldn't do anything with it. That's probably this symbol here being replaced with the value of the current node. Okay, so just adding an if statement somewhere here to only do this if the symbol is not empty. We could, for instance, say if symbol not equal to an empty string, then we're going to do all of this. Okay, otherwise we can just move on to the next symbol. Okay, and that should definitely fix this issue. Let's try just to be sure. I'm going to copy that here. Perfect. And here we've got hello world. Okay. Technically, what we might want to do actually is if the symbol is empty, then we're just going to add a space to our message. Otherwise, we're going to do this. So I could replace that slightly. So if the symbol is empty, I'm going to add a space to my message. Otherwise, I'm going to replace the message, the symbol with the letter. Okay, so one final test, I'm hoping. Good. Perfect. So we're back to our original message here. Now this code works quite well. However, I'm not quite sure what would happen if I start using characters which are not in the tree, like punctuation signs. So I may want to add a few more if statements here to make sure that the character we're looking for is actually in the tree. That it's a letter of the alphabet, for instance. Okay, but you've got the idea here. It works for if we're using it sensibly with letters from the alphabet only and a few spaces if needs be. Okay, I'm going to stop this video here for now, and hopefully you will be able to redo this code yourself. Bye for now.